This is Geometry, Unit 1, Lesson 7 on Systems of Equations. A system of equations, remember, is a set of two and sometimes more equations that have more than one variable that you want to solve for. And you want the values of the variables to work in both equations at the same time. So, there are two methods we learned in Algebra 1 to solve systems of equations. Most of the time in geometry we use the substitution method, so that's going to be our focus for today. So let's look at a couple systems of equations. We have, first of all, the substitution method here. Here is a system of equations. Y equals 2x minus 5 and 3x minus 2y equals 7. We want to find values of x and y that work in both equations at the same time. So let's remember how we do substitution. The first step is to solve one equation for one variable. It doesn't matter which equation or which variable, pick an easy one. Basically that means solve one of the equations for either x or y or whatever variable you happen to have. Sometimes it may already be solved for you. Alright, now notice here, this first equation is y equals 2x minus 5. That is solved for y. So my first step is done for this particular step, or particular problem. Now, it says substitute into the other equation and solve. This says y is equal to 2x minus 5. So that means I can take 2x minus 5, and in the second equation, instead of writing y, I can put it right there. So let's rewrite that. 3x minus 2 times 2x minus 5, which I'm writing instead of y, is equal to 7. So, notice here, I don't have a y for the moment. I've substituted in so that I have all the values are now x. And all I have to do is go through and solve for x. Alright, solve the equation, distribute. 3x minus 4x plus 10 is equal to 7. Combine your terms. Negative x plus 10 is equal to 7. Move the 10 over here by subtraction. 7 minus 10 is negative 3. And then solve for x. You have to divide by negative 1. And x is going to equal 3. So x equals 3 is the x value that will work in both equations. Now, don't forget, we also have a y here. We have to find the remaining variable by plugging the found variable into either equation. Well, I'm going to use the y equals one because that's handy. Y is equal to 2. We know what x is, 3 now, minus 5. 2 times 3 is 6, minus 5. So y is going to equal 1. When we solve this equation, x is 3 and y is 1 is my solution. Now your solution can also be written as an ordered pair. X is 3 and y is 1 is my solution. X is 3 and y is 1 works in both equations. The solution would be 3, 1 written like an ordered pair. Remember, x goes first, y goes second. So if you see the answer 3, 1, you have to know x is 3 and y is 1. Now, the last step is very important as well. Always check in both equations. You can do it on your calculator, that's perfectly fine, but you have to know that it has to work for both equations. So if I'm going to check my solution of 3, 1, here's what I would put on my paper and what I would put in my calculator. I'm going to take my first equation and rewrite it using x and y. So 1 is equal to 2 times 3 minus 5. Now that you can probably do in your head. 2 times 3 is 6, minus 5 is 1. And 1 equals 1 is checked. So if I was doing this in my calculator, I'd enter this half of it and see if it equals 1. Let me see. 2 times 3 minus 5. And it works. It's 1. Now, I also have 3x minus 2y equals 7. So I would plug in 3 times 3 minus 2 times 1 should equal 7. 3 times 3 is 9. 2 times 1 is 2. 9 minus 2 does equal 7. I know it equals 7, but just to check it on my calculator, this is what I'd put in. 3 times 3 minus 2 times 1, use your parentheses. 3 times 3 minus 2 times 1. Oops, so I put a 1 in there. And that should equal 7. And it works. So since this value of x and y, x is 3 and y is 1, works in both equations, that is the correct solution. If you do your check and it doesn't work in one of the equations, you made a mistake somewhere and you've got to go back and fix it. Let's try a little more complicated example. The process is still the same. The only difference is we're going to have squareds in the problem. Let's try this system out. X squared plus 4y squared equals 116. And then we have x minus 2y equals 6. So, our method for substitution says to solve one of the equations for one of the variables. Which one can we solve easily for either x or y? Well, the first one probably not because you have squares there, but look at the second one. X minus 2y equals 6. Would it be easier to solve for x or for y? You can do either one, but it would be easier probably to solve for x in this particular equation. So we want to move the 2y to the other side by adding it. So that's going to give me x is equal to 2y plus 6. I tend to put the variable first for some reason. That's just the way I do it. 6 plus 2y is acceptable. You could do that. Now that it's solved for x, I'm going to substitute in for x into the first equation. Use your parentheses, especially when you're doing squares, because this is actually going to be 2y plus 6 quantity squared plus 4y squared is equal to 116. There is your expression, or your equation, now written instead of x, you have 2y plus 6. Now the reason I said to use your parentheses, because you have to square this entire thing. How do you square 2y plus 6 quantity squared? You have to FOIL it. There's no shortcut. You have to FOIL it. So 2y plus 6 times 2y plus 6, you have to FOIL to get your answer. First, 4y squared. Outside, 12y. Inside, 12y. And last, 36 plus 4y squared. Don't forget the rest of your equation, equals 116. Combine your terms. That gives me 8y squared. 12 and 12 is 24y. And then plus 36 equals 116. So this is a quadratic equation. Remember that a quadratic equation, it has the highest exponent of 2. So that means we have to solve this by first getting it equal to 0. Descending order, highest exponent first, and equal to 0. So we have to subtract the 116. And that gives me 8y squared plus 24y, and then 36 minus 116 gives me negative 80. Now, let's look at the quadratic we have left. 8y squared plus 24y minus 80 equals 0. Now, we could factor it as is, but what do you notice about the coefficients here? They all divide by 8. Why don't we divide by 8 to make our life easier? So I'm going to divide each term by 8, including the 0. Y squared plus 3y minus 10 is equal to 0. Oh, that's easy to factor. This is reverse FOIL factoring. So I'm going to factor y and y. Since it's negative 10, it's going to be plus and minus. And the factors of 10, 1 plus 1 minus, that give me 3, would be positive 5 and negative 2. Now we want to set each factor equal to 0. Y plus 5 is equal to 0. Y minus 2 is equal to 0. So that means y is going to equal negative 5, and y is going to equal 2. Now notice, we have two values of y, which means we're also going to have two values of x. So when you find y equals for each one of these, or x equals, depending on which problem you're looking at, you have to make sure that you find the x that goes with them. So this says x is equal to 2y plus 6. So notice I divided this. X is equal to, when y is negative 5, x is equal to 2 times negative 5 is negative 10, plus 6 is negative 4. X is negative 4. So for my first solution is going to be x is negative 4, y is negative 5. There's my first solution. Now I also have a solution of y equals 2, so what x goes with that one? X is equal to 2 times 2 plus 6. 2 times 2 is 4, plus 6 is 10. So my second solution, I have two solutions here, is going to be x is 10, y is 2. So those are my solutions to that system. Now again, since there are two solutions, you still have to check them in both equations. Again, you can check them on your calculator, is fine. All right, so for the first equation, negative 4, negative 5, I'm going to check that one. I have negative 4 squared. Use your parentheses because you know what happens when you square a negative on your calculator. Without the parentheses, it won't square it. Negative 5 squared equals 116. And then I also have x minus 2y equals 6 or x equals 2y plus 6. You can do either one. I'm going to use the solved one because I think it's a little easier. X equals 2y plus 6 would be negative 4 is equal to 2 times negative 5 plus 6. Okay, Now, this is what I'm going to pop in my calculator to see if it equals 116. All right, get out my calculator, parenthesis, -4, quantity squared, plus, parenthesis, -5, oops, I forgot the 4, 4, parenthesis, -5, quantity squared, and that should equal 116. Let's see if it does. Yep, it does. Now, the other equation was x equals 2y plus 6, so the 2y plus 6 is what I was going to put in. 2 times y, in this case, was -5, plus 6, and it should equal 4, or -4, excuse me. Yeah, it does equal -4. So that matches what we had. So this equaled 116, and it checked, and this equaled -4, and that checked. So -4, -5 works in both equations. We also have to check 10, 2. So if we're going to check 10, 2, we do the same thing. 10 squared plus 4 times 2 squared is equal to 116. Probably do that in your head, really. And also, x is equal to 2y plus 6. 10 is equal to 2 times 2 plus 6. And we can work those out and see if they work. For this first equation here, so we have 10 squared plus 4 times 2 squared is equal to 116. That works. And then for the second one, 2 times y plus 6 would be 2 times 2 plus 6 should equal 10. And it does. So the solutions of -4, -5, and 10, 2 work for both of these. So that is your basic idea of solving a system of equations by substitution. Solve for one variable, plug it into the other equation, solve, use that variable to find the other variable, make sure you check in both equations. And that will be our review for systems of equations.